So in Unit 7, we are going to be talking about probability distributions for continuous random variables. So before we do that, we're going to first today just focus on continuous random variables and discrete random variables. This is going to be a little bit of a review from previous units, but we do need to have that distinction between continuous and discrete random variables before we move on. So if we look at probabilities in a uniform distribution, the example that we have here is the time students spend on a math test ranges equally between 45 minutes and 80 minutes. What is the probability of a student taking more than 75 minutes? So the key word here is it ranges equally. Okay? This is called a uniform distribution because all the outcomes are equally likely. Okay? And we know that this is an example of a continuous distribution because when we're talking about when they're going to finish the math test, they don't have to finish at an exact time. They could finish at 45 minutes and 3 seconds, 45 minutes, 0.78 seconds, whatever it might be. It can be all the decimals in between there. So let's start by graphing this. So if it ranges between 45 and 80 minutes, that's what we're going to put on our graph. So we'll start at 45, 50, 55, 60, 65, 70, 75, and 80. Okay. So we have our graph there. And we know it's going to be an equal distribution. It's going to be continuous. So it's going to be a nice rectangle, and we'll imagine that I used a ruler. That is going to be the probability. And to calculate the actual probability here, we will do 1 over the length of time that there is in this interval. So 80 minus 45. So it's 1 out of 35. So that is how high we go on the y-axis. Okay. And we're trying to find out what is the probability a student takes more than 75 minutes. So we're trying to find out the probability that x is greater than 75. Okay. And if you remember from a previous unit, to find the probability, we can just find the area under the distribution curve. So here, 75 minutes would be there. And if we want it to be greater than 75 minutes, we're interested in this piece right here. Okay. So to find the area of this rectangle, we need the width of the rectangle, which is 5, and we need the height of the rectangle, which is 1 out of 35. Okay. And then we just do length times width, and we get that the probability is 1/7. So next we're going to look at marked distributions in a class. Okay, so we're going to draw our distribution here, and we have marks and frequency. So we'll put frequency along the axis here, so that's going to be number of students really. Okay. And along the bottom here will be the marks. And they gave us the marks in ranges. Okay, and it's range because it is a continuous variable. Marks go from one range directly into the next. And since it's a continuous variable, we are going to be using a histogram, which means the bars are going to be attached to each other. So I've labeled my scales, number of students going 2 all the way up to 10, and the marks 60 to 100, because that's what's covered. Okay, so for 60 to 70, there are 9 students. So between 60 and 70, I would draw a bar going all the way up to 9. Okay, once again, you guys should be using a ruler. I just don't have that option here. Between 70 and 80, there are 7 students. So that would be there. Between 80 and 90, there are 5 students. And between 90 and 100, there are 4 students. So this is a skewed distribution. Okay. So there we have our marks. Okay, and we can shade this in if we want to make it look a little prettier. But there we have our histogram. So this is marks in a data class. Okay, so we want titles, we want all of our axes labeled, and there's our histogram. If we were going to do a polygon, then what we would be doing is we'd be taking the midpoint of each of these bars and connecting it. Good. So if we connect all of those midpoints, then that is our polygon. Okay. And this original piece of data here that we were given, this table with the marks and the frequency, that would be considered a frequency table. And just so you guys know, when we're working with intervals, okay, if the marks ended in 0, they would have been bumped to the lower interval. So you'll see that 70, for instance, is in both intervals. A mark of 70 would go in the lower interval. Okay, so this upper interval actually starts just above 70 and then goes all the way to including 80. And the next one goes just above 80 and goes all the way to including 90. Okay, so whenever you have a boundary that's shared between two different intervals, always bump it to the lower interval. Okay, next example we have is number of siblings. So this is going to be an example of a discrete distribution. You can't have fractions of a person, you can't have all the decimals of a person, you only have complete people. So you only have complete siblings. So I will use the data from one of my previous classes to see how many siblings they had. So 5 people were only children, 7 people had 1 sibling, 3 people had 2 siblings, 2 people had 3 siblings, 0 people had 4 siblings, and 1 person had 5 siblings. Now, because it's a discrete variable, when we're doing the distribution, we are going to draw it as a bar graph. So the graphs is going to have bars that are all separated. So here I'll go all the way up to 7, 2, 4, 6, and 8. Okay, so for everyone, we're just going to do a bar. So for 0, we're going to do a bar going all the way up to 5. And the bars should be equal width. Okay, one bar shouldn't be fatter, for lack of another word, than another one. So go for 1 child, it went up to 7. 2 children, it went up to 3. And that was a little too skinny. For 3, it went up to 2. 4, there was 0, so it would be down here. And then for 5, there was 1. And this is number of siblings in our class. So you always have to begin by looking at what is the variable. Okay, so what is the thing that you're actually studying? And then asking yourself, does it have discrete values or does it have continuous values? Okay, so remember, discrete is when it has to be finite values. There are only specific numbers it can take on. Continuous is when it goes from one number into the next. Okay, so it can take on all those decimals and everything in between. So if you guys have any question, please email your teacher, and have a great day.